8.2 Exploring the Graphs of Periodic Functions. So I just want to highlight something for realsies right here. In order to set your your calculator to graph sinusoidal functions properly, you want to set your calculator to radians. So just to remind you how to do this, I'm going to just clear and I'm going to my mode. So I'm going to go right here. I'm going to click mode and I'm going to scroll down here. See how radian right here is already highlighted? If in fact yours is in degrees, and it looks kind of like that, what I want you to do is scroll down and hit enter when it flashes on radian, so that it will graph properly. Otherwise your sinusoidal graphs will look really wonky, so you don't want that. So today is kind of just our definitions day. I just want us to take some time to write down some of these definitions, and I'm going to give you some questions to work on just to explore these sinusoidal functions. So a periodic function is a function whose graph repeats in regular intervals. So I remember having a conversation with a few of you talking about polynomial functions and how you know it's a graph of a polynomial function if you do not lift your pen when you draw them. Here's the thing, with sinusoidal functions, they kind of look like this. Woo! You're not going to be lifting your pen, so just be careful. It's a function that you're drawing, but it's not going to be a polynomial function. It's a function in that for every y value, or for every x value, there is only one y value, so it passes the vertical line test. But it's not a polynomial function. So the midline. This guy right here is an example of our midline. Half of the graph is above and half of the graph is below. That's how you know what the midline is. So the midline is a horizontal line halfway between the minimum and maximum. The amplitude is from the midline to a maximum or from the midline to a minimum. This right here is amplitude, just as this right here is amplitude. So the way that I would officially define it is the distance between midline and a max, or the midline plus the min. When we're talking about one period, we're talking about one cycle through the shape. So right here is one period, but if I wanted to show you another period, here is another one, this one right here. Okay, this right here would be a part of the third period because it's just where it, and this one right here would be a part of, I guess, the -1, or this right here is part of another, is a part of another period. So the way that we would describe a period in words is the length of the interval over the domain. So it's in the x direction, over the domain to complete one cycle. And this right here is just our key ideas. The function of y equals sine of x is a periodic function. Every periodic function will have a period, it will have an amplitude, it will have a midline. And you'll notice that these are two different sinusoidal functions, but they are they're different. They have different periods. They actually have the same amplitude. Okay, they both have an amplitude of 1, but their periods are much look somewhat different. So y equals sine x. Y equals cos x is our other sinusoidal function. Okay, you can either put it in terms of sine, or you can put it in terms of cos. And again, they're periodic. They have an amplitude. They have a midline. Periodic, so here's the period, they have an amplitude, and they also have a midline. So the graphs of sine x and y equals cos x have the following common characteristics. We have multiple x-intercepts. Okay, so we have an x-intercept here, 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 and we'll keep on going forever and ever. It has an infinite number of x-intercepts. It's only going to have one y-intercept, and thank goodness, because it's a function, so it shouldn't have more than one y-intercept. The domain is always going to be y is an element of the reals, except if we define it differently. The range of just the plain old y equals sine x and y equals cos x is -1 to 1. And if you think about it, that makes sense, because the sign of anything is between -1 and 1. You can't have a sine of something that is 5. You can't have a sine of something that's -10. Neither can you have a cos of something that's, -15, nor can you have a cos of something that is +8. Okay, so it makes sense that it has it goes between -1 and +1. And remember what we learned from the last lesson, a period of 360 or 2 pi, it takes to go all the way around the circle, it takes 2 pi radians, or 360 degrees. So to go through the full range of values for cosine or sine, it'll take you from 0 to 360. And the midline is defined by the equation y equals 0. And again, we're going to do some fancy things here. Okay, we're going to change this up. We're going to give them coefficients. We're going to say x plus 2 and x plus whatever numbers. And then we're going to tack on numbers right at the end like plus 5. But for now, we're just going to be focusing on y equals sine x. Now what I want you guys to do for homework is going to be on page, starting on page 524. And I would love it if you did all the questions. So number 1 to 9. That's going to make tomorrow way easier for you. If you wanted to graph the functions, I'm just going to show you quick here. So I'm going to make sure that it's in radians here, y equals, and I'm going to clear anything else. So I'm going to say y equals sine of x. I'm going to graph it. Oh, and do you see this little periodic function that's happening here? Now, first things first, I'm going to go second, and I'm going to turn my plots off, because I don't need plots right now. I'm going to change my window settings too, so I can actually see what's going on in there. So my window settings, I'm going to go maybe -2 to +10. I like that. And then my y max and my y min, it goes between -1 and +1. So I'm just going to go from -2 to +2, just so that I can see. Not 5, 2. There we go. Just so I can see what happens there. So when we zoom in, oh hey, oh, look at that. Right here, from max to max, you can tell what our period is. from 0 to this 0. Okay, so you can't just go from 0 to 0 though, because this is only half of a period. And if we go up or down, it might not even be half a period. That's how you would graph it. Now, I really like drawing these because they look actually quite pretty together, so I'm going to graph that. Ooh, look at that. And I just encourage you guys to play around with the coefficients. Why not? So if I would say -2 sine x, graph that. Look at that. And just keep on going. It's they're actually quite fun to graph and quite fun to see all together. So tonight for sure, I want you to be doing page 524 to 525 and just play around with your graphing calculator a bit.